In this section of Chapter 8, I'd like to go over homework problems on Lewis structure, formal charge, and oxidation number. Make sure you have a periodic table as I go over homework problems. Let's now go over problem number 47, Chapter 8. So this is 8.47. Question is, draw Lewis structures for the following. So I'm just going to pick a few of those. B is on carbon monoxide, CO. So before I draw the Lewis structure, I must count total number of valence electrons. Carbon is the fourth element in the second line, so it would have valence electron 4, 2s2, 2p2. Oxygen has 6, and you have only one oxygen, one carbon, so altogether we must account for 10 electrons. Now there are only two atoms. Now treat carbon as the central atom because it's the least electronegative. Just by looking at periodic table, you'd know the left hand side elements are less electronegative than right hand side element. CO, and then give noble gas configuration to the outer atom. So give noble gas to oxygen. So I have already assigned 2 electrons. So it'd be 2, 4, 6. So that would be altogether 8 electrons. Now we have 2 more electrons left. We must account for all these 10 electrons. So that 2 electrons would be on carbon. It doesn't matter whether you write down those pair of electrons on the top, on the side, or on the bottom. They all represent that pair of electrons sitting on carbon. Now I'm done with the outer atoms, and I also ran out of all the valence electrons. But what we notice is carbon doesn't have 8 electrons. In this kind of situation, when you don't have extra electrons, then think about making multiple bonds. So what we're going to do next is going to bring one pair from here to here. That would give 6 electrons around carbon. If I bring one more pair, that would give 8 electrons around carbon. So the structure of carbon monoxide is going to be C triple bond O with a pair of electron on carbon and one pair remaining on oxygen. So this is the structure of carbon monoxide. Next we're going to do 47D. So let's do that. 47D. The question is about H2SO4. H2SO4. And they're saying that hydrogen is bonded to oxygen. First, count all the valence electrons. Hydrogen, we know that hydrogen has 1 valence electrons, the first element, and we have 2 hydrogens in this compound, so times 2. So altogether 2. Sulfur is in the same group as oxygen, so number of valence electrons would be the same. That's 6 valence electrons for each sulfur. Oxygen, again, it will have 6. Make sure you look at periodic table, and we have 4 of these oxygen. So that's 24. So 24 plus 6 is 30, 32. You must account for 32 valence electrons. So this is valence electrons. Now we need to identify the central atom and outer atom. Now for the time being, forget about the existence of hydrogen, because hydrogen cannot be central atom. Between sulfur and oxygen, sulfur is least electronegative, or sulfur is present in least number. Either way, you can put sulfur in the middle and put 4 oxygens around sulfur. 1, 2, 3, 4. So that gives me sulfur with 4 oxygen, and give noble gas configuration to the outer atom. Noble gas means 8 electrons around each oxygen, 2, 4, 6, and it already has a pair of electrons. So 2, 4, 6, 2, 4, 6, 2, 4, 6. Now if you count around oxygen, each oxygen now has 8 electrons. So 4 oxygen would have 32 electrons. So that accounts for all the 32 valence electron. Now we need to bring back hydrogen, 2 hydrogens, which we left out. Now, question is saying that hydrogen is bonded to oxygen. So that what that means is you can now stick in hydrogen to any of these two oxygens. Doesn't matter which two you pick. Of course, in this Lewis structure, we are not showing you the shape, but truly it's a tetrahedral shape. And so these are all identical angle-wise 109.5. So let's put one hydrogen in here and the other hydrogen here. Now normally when an electron pair is a bonding pair, we usually write down like this, even though it doesn't matter the way we wrote now is not going to be wrong, but normally we write down like this. Okay, with a straight line joining hydrogen and oxygen. So this is the Lewis structure for H2SO4. Now we're going to do the problem F, NH2OH. NH2OH. Now valence electrons, nitrogen has 5. You can look at periodic table, second line, count electrons until you get nitrogen, that's 5. Each hydrogen has 1, and we have 3 hydrogens in this molecule, that's 3. Oxygen has 6. Altogether we must have 14 valence electrons. Now hydrogen cannot be the central atom. Next we need to determine what is the central atom. So for the time being, you just focus on nitrogen and oxygen. So in this case you'd find that there are 2 central atoms. So I'm going to now write down nitrogen. Nitrogen would be least electronegative here. Of course hydrogen would be least electronegative, but hydrogen cannot be in the middle. So nitrogen, and then I would have oxygen, and then distribute 2 hydrogens around nitrogen. These are the 2 hydrogens with 2 bonds. Remember, outer atoms will have to have a bond, single bond or one pair of electron. And now give noble gas configuration to the outer atoms. Oh, I forgot to write down hydrogen, and that hydrogen has to be bonded to oxygen. So let's write down hydrogen bonded. Now give noble gas configuration to the outer atoms. Hydrogens, when they have single bond, already got the electron configuration of helium, so we cannot have any more electrons on hydrogen. However, look at the nitrogen. The nitrogen has 3 bonds, so 6 electrons, so it needs one more pair of electrons, so let's put it on oxygen, on nitrogen. Now oxygen has 4 electrons having 2 bonds around, so it needs 4 more electrons, 2, 4. So let's now count all the electrons, 8 around oxygen, and then 9, 10, 11, 13, 14. So we have altogether 14 electrons. So make sure you don't count electron pair twice when you're counting total number of assigned electrons. So this gives you the right Lewis structure for NH2OH. Now NH2OH, hydroxylamine, is an organic compound. There is a quicker way of writing down Lewis structure for organic compound. Here I can show you how we can do that. Just keep in mind, for neutral organic compound, nitrogen must have 3 bonds, oxygen must have 2 bonds, and these are valid mostly for organic compounds. So just by knowing that, I'm going to quickly write down nitrogen having 3 bonds, H2, and oxygen having 2 bonds. and that's it. And just now you assign electrons so that nitrogen and oxygen get noble gas configuration. So I can write down quickly Lewis structure just by knowing the fact it's an organic compound. Now we're going to do 51, chapter 8. Here you need to get Lewis structure. So let's write down what question is asking for. Lewis structure, formal charge, and oxidation number. So all these you need to get in this problem. So I'm going to do two problems. Again, I'm choosing 51C and 51D. 51C, so let's write down 51C. Question is, they gave you the formula, which is BrO3 minus. So BrO3 minus. You know that in order to get formal charge, you'll have to draw Lewis structure. For oxidation number, you don't need to have Lewis structure. So let's first draw Lewis structure. And in order to draw Lewis structure, we need to count valence electrons. So valence electrons on Br, which is, you know that Br has 7 electrons, only S and P electrons, or you count along the line which has Br and skip the transition elements, only count S and P electrons, because that's how outermost electrons are defined. So Br would have 7 electrons. So keep that in mind. And then each oxygen would have 6 electrons, 2s2 2p4, or along the line if you count, it'd be just S and P electrons, it would be 6 electrons. And I have 3 such oxygen, 18, and BrO3 is -1. That means you need to add extra electron. So that gives altogether 26 valence electrons. So 26 valence electrons. So when I draw Lewis structure, I must account for all these 26 valence electrons. So central atom is the least electronegative one, or the one which is present in least number. So Br is the central atom, and 3 oxygens would be outer atoms. So let's write down that. So Br, O, O, O. Now I need to work on outer atoms, those oxygen atoms, give them noble gas configuration, or add 6 electrons on each oxygen because they already have 1 pair of electron. Now let's count. 8, 8, 8. That's 24. So I have already assigned 24 electrons in giving noble gas configuration, by giving noble gas configuration to the outer atoms. Now I have 2 other electrons left. Those 2 electrons will have to be placed on the central atom. Never place it on the outer atom because they already have 8 electrons. So now Br also has 8 electrons. So this is the Lewis structure for BrO3 minus. Now let's get formal charge for each element in this molecule. Let's now assign numbers because there are 3 oxygens. So I'm going to use oxygen 1 and then oxygen 2 for the far right one, and then oxygen 3, the top one. And let's draw a line here to clearly see the structures. Okay, now I'm going to count formal charge, and I hope you can follow because formal charge. Oxygen is supposed to have 6 because that's the valence electrons. And now let's find out in oxygen 1 how many would be the assigned electrons. 2, 4, 6 are solely on oxygen 1, not being shared with anyone, any other element. And then it gets 1 from this bond. So that's 7. is supposed to have 6 valence electrons, but here it has 7, so it gained 1 extra electron. So that's -1. Let's focus on oxygen 2. It's the same thing. 6 electrons are solely on oxygen 2, and it gets 1 electron from the bonding pair, so it gets 7. It's supposed to have 6 valence electrons. Now it got an extra one, for which is -1. Oxygen 3 again is the same thing, is -1. Now Br. Let's get the Br. The central atom. It has 7 valence electrons. In other words, it's supposed to have 7. Let's see how many it has in this structure. 2 electrons are solely on Br, and then 3 other electrons are coming from those 3 bonds. So 2, 3, 4, 5. So assigned electron is be 5. So let me write down here 5 for Br, 5 assigned electron, but it's supposed to have 7 valence electrons. Supposed to have 7, but it does have 5. So it lost 2 electrons in this reshuffling of electrons in the Lewis structure. So that, since it lost 2 electrons, Br has to have +2. So these are the formal charges. Let me write down here Fc for each element in Lewis structure that's shown here. Now let's write down now oxidation numbers. For that, we don't need to worry about Lewis structure. So just let me show you how we can do that. BrO3 minus. Only thing you need to pay attention to is all these oxidation numbers added together, just like formal charge, added together has to be equal to the charge on the whole molecule. In this case, it's -1. Now this is how you're going to assign oxidation numbers. For electronegative element, now we know that oxygen is from group 6. Remember, we mentioned this before when we talked about molecular formulas. Group 1A gets +1. Let me write down here. Group 1A +1. 2A +2. 3A gets +3. Beyond group 4, you subtract 8. 5A gets -3. 6A get -2. 7A gets -1. These are oxidation numbers. Now, those minuses are possible only when those elements are more electronegative. In this case, Br and oxygen both cannot have minus. 2 minuses would not make a bond. So think it that way. The more electronegative one can get the minus. So between Br and O, oxygen is more electronegative. So oxygen gets minus. And since oxygen is from group 6A, each oxygen is going to get, let me write down that it's a different color. Each oxygen is going to get -2. For Br, normally when you look at periodic table and find out it's in group 7A, it should be -1. But you cannot have 2 minuses side by side. So assign negative to the more electronegative element and then calculate the value for the other one. So in this case, Br, we need to calculate. How we calculate that? I have 3 oxygen. So total oxidation numbers for 3 oxygen be -6. I'm writing on the top the total number. Br must have +5 because altogether we must account for -1 on the whole molecule. So Br must have +5. And I have only one Br. So my oxidation number, which is expressed for a single element, would be +5 on Br. So let me write down here for Br is +5. For oxygen is -2 because it's always expressed for single element in that compound. So these are the answers to this question. The next question I'm going to do rather within that space that I have, which is 51D, which is HClO2. So that's D. 51D. Question is HClO2. So just write down first Lewis structure, and H is, let's get the valence electron first. Hydrogen is +1, has 1 electron. Cl has 7. I'm assuming that you're following it now. Each oxygen has 6 times 2. That's 12 electrons. And altogether, we have 20 valence electrons. Now leave out hydrogen for the time being and put the central atom between Cl and O. Cl is present in least number, and also Cl is less electronegative. So let's Cl, and then I'm going to have 2 oxygen on both sides, and then give noble gas configuration to the outer atoms, which is oxygen. So it'll be 2, 4, 6, 2, 4, 6. That makes 16. I have 4 more, and I need to place it on the central atom. So that gives you CO2. Now I need to bring back hydrogen. It doesn't matter, it's bonded to one of the oxygens. So let's write it down on the right hand side. It doesn't really matter. And as I said, conventionally, when they're bonded atom, usually we write down the bonded electron pair like this. I'm showing you with a different color. Okay, so that's what you have, and this is Lewis structure for HClO2. Now let's get the formal charges. I'll call it oxygen 1, oxygen 2. I'm going to write down a little bit faster now because they're more experienced now. And I'm going to write down these formal charges at the bottom. Oxygen 1, 2, 4, 6 electrons solely on oxygen 1, and it gets 1 from the bonding pair, so it has 7. Valence electron 6. It's supposed to have 6, but it has 7, so it's -1 formal charge. So these are formal charges in red. Now Cl, let's count for Cl. 2, 4. 4 electrons are solely on Cl, then it gets 2 electrons from 2 bonds on 2 sides. So there's 6 electrons, but it's supposed to have 7. It's supposed to have 7, but it has 6. So this gives me +1. It's +1. It's +1. I think +1 doesn't look too good. Let's rewrite that. Something is going wrong here. Okay, that's better. Now let's count on oxygen. Next to oxygen 2. 2, 4. 4 electrons solely on oxygen, and it gets 2 other electrons from 2 bonds. So 6 is supposed to have 6 because valence electron is 6. It's supposed to have 6. It does have 6. So that means that it didn't gain or lose any electrons. So its formal charge is 0. The formal charge on oxygen is 0. So let's write and draw here. Now let's count on hydrogen. Hydrogen, again, you can see that there's only 1 bond, so it gets the share of 1 electron. Its valence electron is 1. So it's supposed to have 1. It does have 1. The formal charge is 0. Okay, so these are the formal charges then. Hydrogen is 0. Oxygen 2 is 0. Carbon is +1. And oxygen 1 is -1. Let's add up all these charges. +2, and then you have 0 and 0. I'm sorry, I counted it wrong. -1 on oxygen, +1 on Cl. So -1 + 1, that gives 0. And altogether it has to be 0 because ClO2H or HClO2 is a neutral compound. The formal charges added together will have to be 0. Okay, so that's what you have for formal charges. Now we're going to do oxidation numbers. Let's write down HClO2 again. HClO2. Oxygen is more electronegative, so it must get the negative numbers, and it's from group 6, so each oxygen gets -2. And hydrogen is least electronegative, so it can have positive number, which is from group 1A. So each hydrogen is +1. Cl, I need to calculate that. And here, whole molecule is neutral, no charge. So that means oxidation numbers added together must be equal to 0. So let's count that. 2 oxygen on the top must have -4. Hydrogen, 1 hydrogen would have +1. Now what number should I have so that altogether I get 0 because it's a neutral? If it had said it was not neutral, all the charges added together must be equal to the charge on the whole molecule. In this case, let me write down with a different color. Cl has to be +5. Double check it. I'm sorry, that's not right because it needs to be neutral, so it has to be +3. So if you're not careful enough, you can make a similar mistake. So 3 + 1, 4 - 4 equals to 0. So let's write down now all these oxidation numbers. So these are oxidation numbers for my final answer. H is +1, Cl +3, O is -2, not -4. Keep in mind, when you express oxidation number, it has to be expressed for a single element. If I have more than one element, still you're going to write down the charge on single element of that particular element.